Today, we are going to tackle a big one, a concept that trips up a lot of developers, Java multithreading. But don't worry, we're going to break it all down using a story you definitely know, the organized chaos of a fast food kitchen. Seriously, think about it. You go to a fast food joint, place your order, and a few minutes later, everything, the burger, the hot fries, the cold drink, it all shows up at once on your tray. They don't give you the burger and then make you wait 5 minutes for the fries, right? So how do they pull that off, especially during that crazy lunch rush? Well, the secret is that the kitchen is basically running on the principles of multi-threading. You've got multiple things happening all at once in parallel. Someone's on the grill, someone's at the fryer, someone's pouring drinks, all to get your single order out the door as fast as possible. And that right there is the big idea we're going to explore in Java today. Okay, so to really get this, we've got to nail down two super important terms, processes and threads. And in our little story, this is basically the difference between the entire restaurant and the individual cooks who are working inside of it. Let's imagine the entire restaurant is a process. It's its own building with its own kitchen, its own power, its own everything. It doesn't share anything with the restaurant next door. And as you can guess, building a whole new restaurant is really expensive and takes a ton of time. Now, the cooks inside, those are your threads. They all work inside that one kitchen and they share all the equipment, the grills, the fryers, the big bags of potatoes, all the resources. It is way, way cheaper and faster to just hire a new cook than it is to build a whole new restaurant. And that brings us to a definition you should absolutely burn into your memory. Threads are lightweight workers inside the same process sharing memory. The keywords there are sharing memory. That's their superpower. That's what makes them so fast and efficient. Of course, no kitchen just runs itself. You need someone to show up in the morning, unlock the doors, and turn on the lights. You need a manager. And in the world of Java, every single application has a manager called the main thread. When you start your program, the Java virtual machine creates this main thread first. It's the one that gets everything rolling and kicks off all the other work. So we've got our kitchen, we've got our manager, now we need some cooks to actually do the work. In Java, there are two main ways you can hire, or, create, a new thread. The best way to think about these two methods is hiring a full-time cook versus hiring a contract cook. When you extend thread, it's like hiring a full-timer. That cook is now part of the very fabric of this specific restaurant and can't really work anywhere else. But when you implement Runnable, it's like hiring a contractor. The contractor just has a skill. They know how to cook. You can give that task to any worker in any kitchen, and that's exactly why most developers prefer Runnable. It cleanly separates the job from the worker, which makes your code way more flexible and reusable. If you need a simple way to remember that, here it is. This is interview gold. Runnable is the recipe. It defines what needs to be done. The thread is the cook. It's the one who actually picks up that recipe and gets the job done. All right, let's talk about what is, without a doubt, the #1 point of confusion for pretty much everyone learning multithreading. It's the difference between two little methods that look almost the same. But trust me, getting this wrong means your super efficient parallel kitchen won't be parallel at all. So lean in for this one because this is a classic interview trap. Understanding the difference here is the key to understanding how a new thread actually comes to life and starts working. So what's the deal? Well, if our manager calls the run method directly, it's like he decides, you know what, I'll just do everything myself. He cooks the burger, then he makes the fries, then he pours the Coke, all one after the other. No new cook gets hired. No parallel work happens. It's just one guy doing a sequence of tasks. But if the manager calls start button, something totally different happens. That start call is a message to the Java virtual machine that says, hey, go hire a new cook for me and give them this job to do. A completely new thread is created, and that new thread is the one that actually calls the run method. That's how you get real, actual parallel work. So the takeaway is simple. Always, always call start button. Okay, we hired our cook and we've given them a task by calling start. But what does a cook's day actually look like from start to finish? A thread doesn't just instantly appear and start working. Nope, it goes through a whole life cycle of different states, just like a cook showing up for their shift. Let's walk through it. First, when you just create the thread object, it's in the new state. The cook's been hired, but they haven't clocked in yet. The second you call start, they become runnable. That means the cook is at their station, ready and waiting for an order to come in. Once the system scheduler gives it some CPU time, it's running. Now the cook is actually grilling the burger. But what if the grill is being used by another cook? Well, our cook becomes blocked until the grill is free. If they're waiting for a specific amount of time, like on a scheduled 15-minute break, that's timed waiting. And finally, when the run method finishes, the thread is terminated. Shift's over, time to go home. Now, here's a huge point of confusion, another big gotcha. The runnable state does not mean the thread is actively running. It's a bit of a tricky name. All it means is that the thread is ready to run and is just waiting for the CPU to give it a turn. Think of it like this. The cook is standing at the counter, order ticket in hand, totally ready to go. They're just not actively cooking. Yet. Okay, awesome. We've laid a really solid foundation. Now let's talk about what happens when the kitchen gets really busy. What are some of the pro tips and the common mistakes you need to watch out for when you're working with threads? You've probably seen it before during a lunch rush. An order ticket comes in with urgent stamped on it in big red letters. The idea is that the cooks should handle that one first. Well, in Java, you can do something similar. You can set a thread's priority to suggest to the system, hey, this task is more important than the others. But, and this is a big but, there's a twist. And here it is. This is another one of those lines you just have to know. Thread priority is only a suggestion to the thread scheduler. It is not a command. The underlying operating system gets the final vote, and it might completely ignore what you asked for based on a dozen other factors. So the absolute golden rule is this: never, ever write code that depends on thread priority to work correctly. It's just not reliable. So let's do a super quick rundown of the biggest traps to avoid. First, calling run instead of start and wondering why nothing is happening in parallel. Second, thinking that a higher priority means a thread is guaranteed to run first. It doesn't. Third, getting confused between the runnable state, which means ready, and the running state, which means executing. And finally, creating new threads all the time. They're cheap, but they're not free. It's usually much better to reuse them with something called a thread pool, but that's a story for another day. And that brings our whole story right back to the beginning. The only reason that fast food kitchen can survive the lunch rush is because it has a bunch of cooks working in parallel. And in the same way, the reason your application can handle thousands of users or chew through massive amounts of data is by using multi-threading. It's all about doing more than one thing at a time. But this whole idea of sharing leads to a really interesting new problem. If all our cooks are sharing the same equipment, what happens when two of them reach for the very last clean frying pan at the exact same millisecond? Who gets it? How do you stop them from fighting over it and making a huge mess? Well, that particular brand of chaos is called a race condition, and the solution is something called synchronization, which is exactly what we'll be diving into